today. Violations and similarity in the coordinate plane. How can we use dilations to draw similar figures in a coordinate plane? We're going to try to apply similar properties in the coordinate plane and use coordinate proof to prove figures are similar. We need to make sure we know, be able to define like in the day-to-day similar polygon, similar ratio, dilation, and scale factor. Those are bits of information. Okay, if you don't have it written down, I'll come back to it. 3, 2, 1, go. Perfect. Okay. Our math coach wants me to correct this and tell you that figures that are similar have the same shape. So that's all you should write down. Have the same shape. Makes no sense to me. Because it's true that they do not necessarily have the same size. They can have the same size. If figures have the same shape and size, we call them congruent. And you don't have to write this part down here. That's okay. Just write down figures that are similar have the same shape. That's all you need to write down right now. So just put you a period right there. Okay. Figures that are similar have the same shape. What do similar figures have? That wasn't that bad, was it? Okay. We'll add to those principles. Okay. So I'm gonna give you examples of some figures that have the same shape. Check it out. A square with a length of 4 units per side and a square with a length of 10 units per side. It's the same shape. Both the square. Do they have the exact same size? No, if they did, we would call them congruent. Right? What does congruent mean? Identical, correct? Congruent means identical. Okay? But similar just means it has to be what? Okay, so check it out. Triangle 1 and triangle 2 down here. Same shape, yes or no? Yes. Yes. They do not have the same size, but they have the same shape. Over here. Triangle 1, triangle 3. Same shape? No. Even though they're both triangles, we classify our triangles in a particular way. And we'll get to that later this year. Okay? Let's see that. Okay? Same shape. You need to write down the word, the polygons, and this definition. This is the part you need to write down right here. Okay? Do not have to write down the diagram or the statements. We will talk about them later. Similar polygons or 2 polygons. Well, 2 polygons are similar polygons if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. When it says if and only if, that is the strongest vowel that we can take in math. Okay? It's like when I got up to the altar and said, I love you, Stephanie, and only you. Okay? What did you just say? That's what I thought. Alright? So, you hear me? That's like, if you see if and only if, that means that it's true. Okay? That means it's true. It is absolutely true. So, if 2 polygons have corresponding angles that are congruent and corresponding side lengths that are proportional, they are similar. Okay, a couple more seconds to write this down. A couple more seconds. All right. How do we know what's corresponding to what? Well, we got colors here. A, B, C, D, E, F, G, H. Notice how A and E are corresponding, B and F are corresponding, C and G are corresponding, D and H are corresponding. Yay! Right? Match up, letter for letter. Slot 1, slot 1, slot Okay. Sure, it's good like that. All right. So my corresponding angles here, A and E, B and H, B and F, C and G. Check it out. Let's pretend like A and E are congruent, angles A and E are congruent, angles D and H are congruent, angles B and F are congruent, angle C is 80 degrees, and angle G is 81. Yes or no? No. Everything must be congruent in the angles for them to be similar. Okay? Everything. We'll get to the proportions, the side lengths here in a second. Right? Oh, right here. You need to write down this first sentence. Similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. Similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. Okay? Don't have to write this part down, but it's very simple. The similarity ratio of triangle ABC to triangle DEF is 3, 6, or 1/2. Similarity ratio of triangle DEF to triangle ABC is 6/3 or 2. Notice how this is written. Smaller triangle to be bigger triangle, correct? Right? Smaller to bigger has a ratio of 1/2. Bigger to smaller has a ratio of 2. Okay? Happy? We'll discover our side length for this next example. Right? Come on, Riz. Time's up on Riz. Right. Come back to it later. Next we get to this. Last big word. Determine whether the polygons are similar. What am I trying to do here? What? Very good. Not a trick question, right? Just want to make sure we read directions in here. Do we read directions? We read directions. All right. If so, I'm going to write the similarity ratio. What's the similarity ratio? Have y'all figured out school yet? Like, you guys haven't figured out what's up. I mean, we say the same thing like over and over. We have to write them down. That's typically something that we're going to ask you later in the lesson. So that's school, guys. That'll be school for a while. Okay, so if you want to play school, play school. All right. What's the similarity ratio thing? Okay. And what does it mean if they're similar? Thank you. All right. Good. Play school. Okay. All right, check it out. Rectangles ABCD and EFGH. Okay. Watch how I color these. Okay. A to B, E to F. Let's see that? A to B, E to F. A to B over E to F. It's going to be proportional to B to C over F to the G. B to C over FG, which is going to be proportional to C to D over G to H, which is going to be proportional to D to A over H to E. Now, right now it won't make much sense. Let's think about that. Does that make too much sense? Now I got to fill in some numbers here, okay? First off, rectangle, opposite sides are congruent. congruent, which means B to C is 9 and A to D is 9, B to A is 6, C to D is 6. Over here, 6 and 4. Okay? Check it out. What's the length of A to B? What's the length of E to F? What's the length of B to C? What's the length of F to G? This is not hard. What's the length of C to D? What's the length? Thank you. What's the length of D to A? Okay. All right. Now, that looks funky down there, correct? It's really, really funky, right? Yes? Watch what happens here. That's what I do here to complete my statement. Okay? What is 6-4 in simplest form? We say 3 over 2. Okay? 3 over 2 is acceptable here. 3 over 2. What is 9/6 in simplest form? What's 6 over 4 in simplest form? What is okay. So in simplest form, I have what I call proportionality. Proportion. Okay. Right, a rectangle ABCD, right, is 3 over 2 times bigger than whatever that would be. 1.5 times bigger than EFGH. Okay. Right? Are they congruent? No. What is congruent mean? Are these identical rectangles? No. But do they have the same shape? Yes. And are their side lengths proportional when I put them in a ratio? Yes. Watch how I would write this particular similarity statement. It's really difficult. Don't pick up on it. Rectangle ABCD. How do I signify something is similar? CJ. Man, how's something similar? What do I symbolize it as? Help me out. Yeah, a single squiggly line. Okay, means similar to triangle EFG to the H. Right? Real quick, crash course lesson. This is not difficult. You probably should write this down. You should know it. What does that mean? What does this mean? I just said it. I'm not hearing anything. Similar. What does, when we put it together, what does that mean? No. It's not yesterday's text. What does it mean? We talked about it. What's the C word? Congruent. Okay? Congruent. Didn't say about that. We talk loud in here. Open your ears. I got big old ears and I can't hear you, which means you weren't loud enough. Okay? All right. Here is the steps involved in what I just did. We didn't talk about congruent angles because we haven't talked about properties of rectangles. Rectangles have how many angles? 4. How many? All of the angles are, stand up. You, stand up. All of the angles are what types of angles? With your nose. I ain't gonna write this stuff down. Stand up. Notebook right here. You go. Right. They're all right angles. Right angles are all how many degrees? Very good. Okay. So they would all be congruent angles. And then you see how my corresponding sides are all proportional. Okay. Notice how they answer the question. Similarity ratio is 3 over 2. And rectangle ABCD is similar to rectangle EFGH. Okay? Right? Need to write this down. Yes, all of that needs to be written down. dilation is a transformation that changes the size of the figure, but not its shape. The pre-image and the image are always similar. Stop right there. Coming into class today, you guys do 3 different transformations. What were they? Rotation, reflection, translation. Okay? In each of those transformations, when I made those transformations, the size and the shape of the figures stayed the same. We call those what? I. I what? Isometry. There we go. See, I heard that time. Okay? Isometry or isometric, right? They're rigid transformations. And I said one day we would talk about something that wasn't a rigid transformation. CJ, you write this down? Would it be better if you sat down? Okay, sit down. Don't fall asleep. Don't pick it up. Right? A dilation is not an isometry because the size of the figure changes. Okay? And here's how it changes. We do what's called a scale factor. We apply a scale factor. It describes how much the figure is enlarged or reduced. It says for a dilation with a scale factor K, you can find the image of a point by multiplying each coordinate by K, such that AB would turn into K times A, comma, K times B. Makes no sense. I'll explain it to you. If I started earlier today, I gave you a warm-up, and in that warm-up, I said I wanted you to multiply 6 times 1/4. Imagine I gave you coordinate points 6, comma 6. And I said apply a scale factor of 1/4. You would multiply 1/4 times 6. When you did that in the warm-up, what did you get? 1.5, correct? So if I started at 6, I would then end up after the scale factor at 1.5, comma 1.5, correct? You can go the other way with the scale factor. Instead of saying a scale factor of 1/4, let's take a scale factor of 4. If I multiply 0.66 by a scale factor of 4, where do I end up? Say it louder. Right, say it louder. What? Sure. I have a scale factor of 4, the coordinate points of 6. If I multiply my scale factor times my coordinate points, what are the new image coordinate points? 24, 24. 4 times 6, 24. Correct? Okay. So that's how a scale factor can either enlarge or reduce. Okay. This helpful hint is very, very helpful. If the scale factor of the dilation is greater than 1, I do this. K is greater than 1. It is an enlargement. It's going to get bigger. If the scale factor is less than 1, K is less than 1, it is a reduction. Okay? Reduction. Enlarge, reduce. All right? So, trick question. What if I have a scale factor of 1? Does my image get bigger or smaller? That's why it's a trick question. It stays the same. What if I multiply 6 times 1? What do I get? 0 times 1. Your mama times 1. Your mama. Good. Your mama times 1 is your mama. Okay? You can't make it your mama. Say what? Very good. anything times 1 is itself. Okay? Anything times 1 is itself. Anything times 0 is 0. 0 is the all-powerful 0. Okay? Alright. You don't have to write this down, just look up here, please. You have a nice picture of a pony. Okay? It's a picture of a pony. Alright? It says draw the border of the photo after a dilation with scale factor 5/2. 5/2. What is my scale factor? Not your question, right? Remember, it goes back to plain school, okay? 5/2 is the scale factor. Okay? Check it out. I take that scale factor, I multiply the scale factor by each coordinate point, not just each set of coordinate points. I'm sorry, not just one time, but notice, I multiply the scale factor for both coordinate points, correct? The x and the y value, I apply a scale factor. 0 times 5/2 is anybody. 0 times 5/2 is 0. Point A, here's the big hint. If you ever get anything that's positioned at the origin and you apply a scale factor, it's still going to be at the origin. 0 times 1/2 is what? 0 times 5 is what? This is not that hard, right? So don't come to me with a question about the origin. I know, because I've already been over it. Some of you are sleeping, right, Douglas? Get up, Douglas. All right. Everything else I apply a scale factor of 5/2. Okay? What's going to happen? Is this picture going to get bigger or smaller? Bigger. We call that enlarge or reduce. It's going to enlarge because my scale factor is bigger than 1. Oh, my pretty pony just got bigger. Okay? Picture of the pony. All right? Let's do this on our own right here, okay? I want to write down, you don't have to write down the diagram. Let's start off with the coordinate points. A is at 0, 0. B is at 0, 1, 2, 3, 4. C is at 1, 3, 4, 3, 4. And D is at 3, 0. Right? Everybody, please apply a scale factor of 1/2 and write down my image coordinate points. This is the pre-image coordinate points. I want the image coordinate points. So you're writing it down. You got it? Corey, I'll do A. Actually, you know what? I'm going to let Chandler. What did you do A? Chandler? When I apply scale factor of 1/2 to 0, 0, what is my new set coordinate point there? Awesome, man. Corey, B prime. What you got? Very good. Did you multiply 4 times 1/2 to get 2? Good. Right here. 3, 4, what you get? That's right. 1.5 what? 1.52. Okay? Right? We go back here. What you get? 1.50. Alright, guys, it really is, it honestly is that easy. Doing evaluation is the hard part, typically finding a proportionality. Okay? Finding that ratio. Once you get that ratio, it's just simple multiplication and writing down new coordinate points. Okay? This is straight up. The answer, how you would do it, no big deal. We can tell right now, would this be an enlarged or a reduced image? Reduced image Because my scale factor is what? Less than or greater than 1? Less than 1. Less than 1. Okay? If it's 2, it's going up. What happens if it's 1? Stay the same. And yes, you'll get that on the EOC. And no, I don't know why. Okay? We're going to tell you apply a scale factor of 1. I've seen it before. And you sit there and you're like, and they want to test to make sure you understand the scale factor. Okay? We don't have to do that one. We are going to do this one. Woo! What am I trying to do here, Heather? Why don't you read the directions? That's usually a good starting point. Go ahead. Good. Okay, so that very first phrase, got that English, right? Introductory phrase, right? Given that triangle TUO is similar to triangle RSO, that's a lot of information, correct? All of the angles are what? They're the same as they congruent, and the side lengths are not congruent. Not the best word. Proportional. They're going to have the same ratio. Okay? See how this works here. I want to find the coordinates of U. Okay? Watch how I do this. Let me ask the question first. If I go from 0 to R, did I go -12 or did I go 12? No, sir. Absolute value of -12 is 12, correct? If I said, what are the coordinates of R, you say -12. Got me? But if I say, how many units did I travel? How many units did you go to the left? 12. You're confused on that? I'm confused in general. What you confused about? Everything? Triangle? Well, it is -12, 0. Those are the coordinate points. Okay? But if I say, how far is it from 0 to 12, or from 0 to R, what would you say? You wouldn't say it's -12. You just say it's 12. It's the absolute value. Okay? It's a distance measurement, not a coordinate measurement. Does that help? Okay. All right. So if I have my triangle, first thing that I want to do, and they show you how to do this. Okay? They show you how to set up a proportion. I've done this before. It's just cross multiplication, right? A ratio. Y'all did this. I know y'all did this. I asked Ms. Gray. Y'all did this. Okay? We said R to O is 12, correct? T to O would be 9. Yes? Y'all see that? T to O in distance would be 9. So 12 over 9. And this says equals because it's going to be proportional. Y'all got me? That equals is really important in there. It's equal because it's proportional. Okay? So that doesn't make sense. 12 does not equal 16. Right? And we don't know, but 9 would not equal OU unless OU was 9. Right? But when you put it in that fraction, now you're dealing with a ratio and proportionality. And that's when you got to start thinking, okay, I'm taking this to the next level. Math to the next level. We don't know what U is, so it's our variable, so think of it like that. What would I do in that situation? To solve for X, what do I do? Cross multiply. 12 times X is 12X. 9 times 16 is 144. How do I isolate X from here? Divide those. I know. I didn't catch it at first. Okay. That means that my proportionality here, 12 over 9, should equal 16 over 12. Correct? Y'all see that? That's how you find out what your proportion is. That's how you find out what your proportion is. We're going to work this a lot today in the lesson. Okay, because obviously it's not something that you Okay? What do you get in this particular proportion? What does this ratio boil down to? Somebody tell me. 4/3 equals, how many times does 4 go into 16? How many times does 4 go into 12? You'll love this about geometry. A lot of times it's insane. Okay? A lot of times it's congruent, a lot of times it's proportional. That's not a hard problem on its own. It's like, why'd you put all of those shapes and numbers and everything? All right? Okay, so to solve this entire problem, I would sit there and I would sit there and I know what my ratio is. If I multiply the coordinates, so back here, this is how they get the scale factor, okay? Yeah. If I multiply the coordinates 0, 16 by a scale factor of 3/4, I'll get my coordinates of u. All right, now I really want to put this lesson and tie it all together, and I'll give you a break. Guys, why would I multiply by 3/4 and not 4/3 to go from y to u? Use a similar triangle. Okay, listen to my question carefully. To find the coordinates of u, and I'll give you, I'll let you know right now, it's going to be 12. Okay, your answer is going to be 0 to 12. Why would I multiply by 3/4 instead of 4/3? Yes, ma'am. You're close, but it's a geometric. It's something we talked about today. It's not. I'm not asking you some off the wall principle. Yes, ma'am. They're not congruent. I'm gonna draw. Watch this. I'm gonna use some coloring techniques, and you're gonna understand the question better. Why would I have to multiply by 3/4 instead of 4/3 if I wanted the blue coordinates to become the red coordinates? Because it's reducing it in size. Remember that scale factor? If I multiplied the coordinates by 4/3, it would do what? Enlarge it. But since I'm multiplying by 3/4, it is going to shrink it or reduce it. Okay? All right. Any other questions on that?